Yes, Alina, now let me know if my voice is clear. Yes, okay. So let's start the class now. Pay attention on the lecture today. Today, this is our lecture number 23, and we are reviewing the chapter Force and Pressure. Please focus on the lesson. I want all of you to please open your book on page number 240. Today, we are recapping the entire lesson. Please open your books at page number 240. Up till now, we have learned in this chapter, we have learned that force is a push or pull, the different types of forces such as lifting, stretching, twisting, pressing, frictional force, gravitational force, and magnetic force. We have also learned the effects of forces such as change in shape and size of an object and the change in the state of rest or motion of an object. About frictional force and its positive and negative effects we have learned. We have also learned about the magnetic force and its daily applications. Nida, what's the matter? Nida Fatma, behave yourself because you were distracting the class by using the annotation. You are not allowed to use annotate. Understood? You are here just for learning, not for fun. Okay. We have also learned about the gravitational force, and SI unit of force. Can anybody let me know what is the SI unit of force? Write down in the chat box. Yes, everyone. Start writing about the yes and small n. Hamza Anjum. Beta. Miram. Yes, you said right. Miram, right. Okay, Nida Fatma, but be careful about the next time. Okay, yes, capital N. It's Newton, capital N. Good, good, everyone. And we have also learned about the pressure and its SI unit. Now write down the SI unit of pressure. SI unit of pressure. Yes, good. There are two units we have learned. Pascal, PA, and another one is, can anybody tell me about the another one? No, Newton. Zen, this is the unit for force. I'm asking about the pressure now. Yes, good. Good, Sohema. Pascal, there are two units for pressure we use, Pascal and Newton meter square, Nm raised to the power minus 2. Right. Okay, now force. What is a force? Write down the definition of force in the chat box. What is a force? The simple definition, simple and very straightforward definition of force. How do we define force? Yes, Nida. Yes, Miram. Exerted by one object on another object. Force is a push or pull exerted by one object on another object. Okay, we can't say only that push or pull exerted by an object. No, a push or pull exerted by one object on another object. Now we will learn about the action and types of forces. Actions to apply force. There are several different types of action by which we apply force, like lifting, pressing, twisting, stretching. Please give me one example of lifting force. Please write down any one example of lifting force. Yes, Ayan, good. Write down the example of lifting. Then Yes, one definition, one example for lifting force and another example for pressing, twisting and stretching. Lifting, like if when we lift the carton or lift the box from the ground, this is an example of, yes, lifting a box. Another example for pressing a foam or mattress. Twisting, yes, twist the sponge, good. Pressing a duster, good. Good, Miram, Omar. Yes, Yusera, the weight lifter is lifting the weight, excellent. Pressing a duster. And what about the stretching the hairband? Girls use girls when they tie their hair with the hairband, they twist it, they stretch it. Stretching a rubber band, stretching a hairband. Okay, good. Now move to the next one. Types of forces: contact and non-contact force. We have learned three different types of forces: uh, frictional force, magnetic force, and gravitational force. Frictional force is a contact force. When the two objects or two surfaces are in contact, then they produce a frictional force. However, non-contact forces are magnetic force and gravitational force. Okay, here there are some examples of contact forces and non-contact forces. Now, contact forces experienced by bodies when they are in physical contact with each other. Like these boys, they are pushing the box or carton. It means they are using their muscular force, and the force which is being produced by the box and the floor is the frictional force. So here you can see the box is being pushed in the forward direction, but the surface is producing the opposite force. When the box is rubbed against the surface of the earth or surface of the floor, it produces frictional force. So force due to the action of muscles, it's a muscular force. In your book it was not given, but I'm explaining you, I'm telling you just for your extra information. Okay, and you have learned in your book about the frictional force. We have discussed it so many times that force acting opposite to the direction of motion is called the frictional force. When two objects, they come in physical contact or rub against each other, they produce frictional force. Now, non-contact forces, forces experienced by bodies even if they are not in physical contact with each other. Like magnetic force, if magnet is kept at some place in its surrounding, it produces a magnetic field where the magnetic force acts. So anything when it comes near the magnetic field or near the magnet, it produces magnetic, if it is attracted by the magnetic force or magnetic field, and magnetic force is produced. Likewise, electrostatic force is force exerted by a charged body on another charged body. In your book this electrostatic force is not given, but you have experienced it several times. During the winter season, when our hair are dry, they produce electrostatic. Okay, Alina, they produce electrostatic force. When we rub, when there is a charge particle moving, then it produces electrostatic type of force. This is produced due to the movement of charge. Okay, at gravitational force, it's a force of attraction between two masses or two objects. Like here in the picture you can see surface of the earth. Boy is standing on the surface of the earth and he is throwing the ball in the upper direction in the air. What happens? The ball is rotating and it is coming downwards due to the gravitational force of the earth. Okay, anything which we or any object when we throw it in the air, it comes downward due to the gravitational force of the earth. Okay, tell me if this is all clear. Electrostatic force, I'm repeating. Here in this picture, you can see the papers when we tear the paper in very small pieces, and if we bring the comb or anything, any object near to them, they tend to stick to them. This is due to the electrostatic force, or electrostatic force is a non-contact force, and it is produced or exerted by a charged body on another charged body. Okay, Nida Fatma, what do you want to ask by writing this? Who are you? I think you are not intended to take the class. If you don't want, please, you can go. But you are here just to distract the others, the teacher and the others, your class fellows. If you are here, if you want to be here, please focus on the screen. Okay, now next is, let's watch a video on contact and non-contact force. Please class, let me know if you hear the voice of the video. Voice that is in the video, not my voice in this video. Please quickly let me know if you can hear that voice. Yes, Hania, Hamza, Anjum, Aiza, please, beta, Alina, let me know if you hear the voice of man. No. Okay, then I will explain it. Okay, I will explain it. Okay. So in this video, they are explaining the contact and non-contact forces, contact force and non-contact force. Some examples they are giving. In this video, they have given us the examples of two different types of forces, contact force and non-contact forces. Now, first of all, they define a force as a push or pull that acts on an object due to its interaction with another object. You can see that exerting a force of 5 Newton, the hand is exerting a force of 5 Newton to the right direction. Okay. Now again, the objects that are physically touching each other are called contact forces. Non-contact forces, they don't require the object to be touching. Like friction is a contact force. Air resistance is a contact force. Now, tension is a contact force. The rock is being held by a rope, and it is producing a contact force. These are the normal contact forces. Reaction force, like a big size ball is kept on the table. It is exerting a force on the table. This object is exerting a force on the table. So the force it exerts, it has, due to which it has some weight. Equal and opposite force is being exerted, and it's a normal contact force. Okay, gravitational, magnetic, and electrostatic force. In non-contact force, we have learned gravitational, magnetic, and electrostatic force. Field of influence, like gravity, it is the force of attraction between two masses. If we are on the floor on the surface of the earth, we can stand properly, but if we move away from the surface of the earth, we lose gravity. Likewise, magnetic forces, attractive and repulsive forces. Okay, attractive and repulsive forces. Attractive forces, opposite op, positive and negative poles, they attract each other. Same poles, they repel each other. Okay, now next is the friction. What is friction? What is friction? Yes, we have discussed the friction so many times, and it is the opposite force that is being exerted by the objects when they rub each other. Like in this picture, you can see that the box is being pushed on the floor, and the floor is exerting a force in the opposite direction of motion. Okay. Now, effects of friction. First one, can anybody explain me this in the first picture? What is happening in the first picture? In this picture, they are showing the grooves, grooves in the sole of shoes, ball bearing, that why ball bearings are being placed between the sliding surfaces. Can anybody tell me? Yes, Hania. Hania, do you want to tell me the answer of this question? Yes, grooves on shoes help us to walk properly. They reduce the friction. Okay, they help us, grooves on the soles of shoes, grooves on the tires, ball bearing, they all ball bearing between the sliding surfaces, they all help us to reduce the friction, to reduce the negative effect of the friction. Likewise, here in this picture, you can see that the man is using the skates. He uses the skate to run or to walk on the floor, and and on the another foot he does not he is not using the skates. That's why it is easy for him to slip on the floor or to walk easily on the floor. It reduces the friction of the floor. Here in this picture, what is happening? Yes, Hadika, right. Yes, Sarah. Yes, good. Yes, what is happening in the third picture? Yes, class. What is happening in the third picture? In this one, the this boy, focus on this screen, that this in this picture, this boy, he is running on the uh, he's running or walking on the floor or garden without wearing any skate shoes. However, this boy, he is walking or he is skiing by using skies. Both of the both type of walking or the skies, they help the boy to move easily or to reduce the friction or to, yes, yes, they are sliding, the children are sliding. One is using the skier to reduce the friction or to increase the surface area, right? Next one, streamlined shape, reduce fluid viscosity. All those objects we have learned, all those objects underwater and in the air, they are streamlined shape. They have a streamlined body which help them to resist the water friction. Okay, likewise here we use friction in writing. We here in this picture, the parachutist, he is coming down on the earth using the air resistance to land safely. Right? Understood? Okay, next is, yes, okay. Next is magnetic field and magnetic force. Now there is another video to show the magnetic force and magnetic field between the surfaces. Okay, class. In this is the bar magnet. You have seen it so many times in your daily life and in the books or pictures as well. When we keep the bar magnet at a place and try to bring a iron nail near it, the iron nail attracts towards it and tries to attaches itself with the bar magnet. This is due to the force of attraction between these two objects. Because bar magnet, it produces a magnetic field where the magnetic force acts, and nail near the when we bring the nail near the bar magnet, it attaches with the magnet due to the magnetic field and force of attraction. Is the This is the non-contact force. This is not the contact force. Okay, this is the non-contact force. You can see that iron nail attaches itself to the bar magnet due to the force of attraction between these two objects. See, when we are moving the direction, when we are changing the direction of the bar magnet, the nail is also changing its direction according to the magnetic field or the magnetic force. Look, these are not attracted towards each other. Sorry, these are not attached to each other. They are just attracted to each other due to the magnetic force and magnetic field. It is a type of non-contact force, and since they are away, little bit away from each other, even that the magnetic field is produced between these two, and this magnetic field attracts the or magnetic force attracts the nail towards itself. That's why when we change the direction of the this bar magnet, the direction of the nail also changes, or we can say that the nail is also changing its direction according to the bar magnet. Here you can see clearly that magnet is attracting the nail towards itself by the invisible field that is called the magnetic field. You cannot see the magnetic field, but you can feel it. Okay, magnetic field is invisible field, and you can only feel it by bringing different metallic objects near the magnet. Strength of the field constant throughout, but it is strongest at the poles. The example of magnetic field is same as we use the Wi-Fi connection or we use the mobile phones where we cannot see any field around them. But they work, they are invisible. The Wi-Fi, we cannot see the Wi-Fi, but it attracts our cell phones, or it is connected with our cell phones or our electronic devices. They are connected to the Wi-Fi due to the Wi-Fi signals. Likewise, since they are also invisible, likewise the magnetic field, they are also invisible. And the field is the strongest around the magnet, but it is the strongest near the poles. Near the at the south pole and the north pole, the field is strongest. Okay, now next is gravity or gravitational force. Gravity or gravitational force, it's actually the Earth's gravitational force that pulls everything towards the center of the Earth. In this picture, see the sun is the larger object or the largest object as compared to the Earth. But there are the on the Earth, since they are far away, that's why their force of attraction is very minimal, very small. We are standing on the surface of the Earth, that's why the force of attraction of the Earth is very large, and it pulls the objects towards itself. And because of this force, the book, table, chairs in the room stay in place, and dropped objects fall to Earth rather than moving together towards you. Okay, everything, they are at their place on the surface of the Earth. If we keep them on the table, like our books, our chairs, our all the objects, they, when we try to throw them in the air, they come down towards the surface of the Earth due to the gravity or the gravitational force of the Earth. Now pressure, beta, one thing I want to tell you, if the class will be disconnected, I will reconnect it again. Please don't go, wait. Okay, so pressure, we have learned the pressure, that it is the force acting per unit area. Here the formula for pressure is written: pressure is equals to force acting per unit area, or F upon A. Here in this example, I have shown us that 100 Newton of force is being exerted by some object, this block, on a particular area. If we divide the force, that is in the form of weight of that box is exerting a force of 100 Newton on area of 0.1 meters square. If we divide the 100 by 0.1, then our answer would be 1000, that is 1000 pascal. The pressure would be 1000 pascal. Same is the case if we increase the area, if we decrease the area, the pressure would be increasing. Okay, what happens? I have told you that if force increases, pressure would be increases. If we decrease the area or increase the area, the pressure would be increasing or decreasing. If we increase the area, pressure decreases. If we decrease the area, pressure would be increasing. Okay, means both are opposite to each other. Understood? And now here are you can see one is the foot of elephant. One is the foot of elephant. It is exerting low pressure, and another is the stiletto or the heels of the lady's shoes. It is exerting high pressure. The foot of elephant, it's exerting low pressure. However, heel the heel of the stiletto is exerting high pressure. Why this is so? Give me the reason. By the time, write down the reason by the time I'm marking your attendance. Write down the reason you understand according to you, so that I will come to know that you have better understood it. Yes, Alina, because the area covered by elephant is large, so pressure is yes, good, good. Anyone else? Is this is this answer correct? The foot of the elephant is taking larger space and exerting low pressure. And what about the stiletto? What about the stiletto? Is it okay now? Can you hear me? Okay. Now here we have since all of you have given me the correct answers, let's just finalize it. High and low pressure. Why the feet of an elephant uh, exerts low pressure on the earth? However, its body is huge and largest in size. An elephant exerts relatively low pressure because of the surface area of its feet, that it covers high surface area, more surface area, and low pressure, whereas a woman in the stilettos exerts a lot of pressure because of the low surface area of the heel. You can see clearly that the heel of the shoes of the woman, it covers very small area, but it exerts high pressure. Okay. Yes, Varda, right. Okay, now next is reinforcement questions. Question answer session. Why wet racing tracks are dangerous? Question number one. Why wet racing tracks are dangerous? Why this is so? Start writing the answer in the chat box. Beta, quickly, the time is getting short. Just few minutes are left. My question is my question is why wet racing tracks are dangerous because of the yes, if the wet tracks are accident, it wet tracks reduces the friction. Your simple answer should be the wet tracks reduces the friction and it may lead to the accidents. Name the frictional force which resists the speed boost. Name the frictional force which resists the speed boost. Yes. Only Alina is answering. Yes, right, you Sarah. Which force helps the parachutists to land safely? Which force helps the parachutists to land safely? Iman, water resistant. The body is streamlined of the speedboat. The body of the speedboat is streamlined, which helps to resist the water resistant, or the frictional force which is present in the water is the water friction or water resistance. Okay, how an excavator moves easily on soft ground? Which thing, which part of the excavator helps it to move easily on the soft ground? How an excavator moves easily on soft ground? Next question, we have already discussed about the skiers that they wear skies to walk easily on the soft snow so that it covers the large surface area and put low pressure on the snow so that they won't sink down in the snow. Okay. Excavator, no, you said excavator, the large machines which used to dig the ground, dig the soil. It's not handrail. Excavator. Okay. Okay, class. Now, before winter vacation, this is your last lecture. We will meet after the winter vacations. And today, no written assignment would be uploaded. Only learning and reading homework will be given. Okay, I will be uploading it just after the class. And hope you will enjoy your vacations and do not forget anything what we have learned in this chapter, or I believe that everyone has very good preparation, perfect preparation for midterm exams. Okay. Yes, yes. Okay. Okay, thank you. Allah Hafiz. Allah Hafiz class. Yes, Varda.